Now we're going to be looking at adding, subtracting, and multiplying radicals. Let's say I'm adding 2x squared plus 4x squared. I'm allowed to add these because they are like terms. They both have the same last name, x squared. When we add them, we just add the coefficients and tack on the last name x squared. This property also goes for adding and subtracting radicals. We must have like radicals. Now, to have like radicals, you have to have the same index and you have to have the same radicand. And if we have both of those, we have the same last name, which we just tack on at the end, and then we add or subtract the coefficients. Sometimes two radicals will appear as if they cannot be combined because their last names are not the same. But remember, before deciding this, you must try to simplify every radical. So in this problem, I have 2 times the square root of 20 plus the square root of 5. Now, right now, my last names are not the same. They are both square roots, but the radicands are different. Now, if we look at 20, the square root of 20 can be broken down into the square root of 4 times the square root of 5. Now, we know that the square root of 4 will give me a 2 that will hop out to multiply in front of the radical. So then I can simplify that to 4 times the square root of 5 plus 1 times the square root of 5. Now, we don't normally write this one, but it's always there. So now that I have the same last names, I can go ahead and add my coefficients, 4 and 1, and I can simplify to 5 times the square root of 5. The order in which you simplify does not matter. You can take the nth roots and pull them out of the radicals and then combine like terms, or you can combine like terms and then simplify the radicals. Now, I personally believe that it's easier to combine all your like terms and then simplify the radicals. So in this problem right here, the first two terms are like terms. They both have the same last name. So we can go ahead and subtract the coefficients. So I'm going to be left with 1 cube root of 2x cubed minus the square root of x cubed. So notice 1's a cube root, 1's a square root. That's why I can't combine them. Now this first one here, since I have x cubed and my index is 3, the x will go ahead and pop out of the radical. Now this second one I can rewrite as x squared times x. Anything to the second power will hop out. So my final answer will be written as x times the cube root of 2 minus x times the square root of x. Now you want to make sure you look over your problem and there's nothing else to be simplified, and then we are done. These first two terms are like terms because they both have the same last name. So let's go ahead and subtract their coefficients. I cannot combine the remaining terms because one's a fourth root and one's a square root. Now we want to rewrite the first term so everything's to the fourth power. Well, 81 can be rewritten as 3 to the fourth power. X to the fifth can be rewritten as x to the fourth times x. And this last guy, we want everything to the second power. So let's go rewrite that as x squared times x. So anything to the fourth power will hop out. So this 3 will hop out, and this x will hop out. Now remember, they always multiply what's in front. Now back here, anything to the second power will hop out. So the x will come in front of the radical. So now we simplify, we get 6x times the fourth root of x minus x times the square root of x. And that is going to be my final answer. When multiplying radicals, the only requirement is that you have the same index for both radicals. And if you do have the same index, you just multiply the radicands together and then, of course, simplify. So in this first example, I have a cube root and a square root. So my index is 3 and 2, which means we cannot multiply these together. So in simplest form, you would just rewrite the original equation. Now for the second example, the index of the first is 3, the index of the second is 3. So I can write them underneath the same radical and just multiply what's underneath. So I'm going to have negative 4 times 2 x squared times x. Now we can rewrite this as negative 8 x cubed. Now we know that negative 8 can be rewritten as negative 2 cubed, and then we have x cubed. So anything to the third power will hop out. So a negative 2 will hop out, and an x will hop out, and I'll just be left with negative 2x. All of the cube roots go away. To multiply binomials that have radicals in them, you double distribute just like you normally would if you didn't have radicals. So for this problem, we're going to do 3 times 2, 3 times negative 4 times the square root of 5. Now remember, you just multiply what's in front. So I'm going to get negative 12 times the square root of 5. And then we multiply the next terms. I multiply what's in front, so I'm going to get positive 4 square root of 5. And then multiplying the last term, we just multiply the coefficients, so that's going to give me negative 8. And then we multiply what's underneath since we have the same index. So I'm going to get the square root of 25. Now I combine like terms. Well, I have just a lonely 6 here. Then I have negative 12 square roots of 5 and positive 4 square roots of 5, which is going to simplify to negative 8 square roots of 5. And then I have this negative 8 square root of 25. Now remember, the square root of 25 is 5. So now I need to combine this positive 6 and this negative 40. So combining the positive 6 and the negative 40, I'm left with negative 34 minus 8 times the square root of 5. And that's going to be my final answer in simplest form. Go ahead and try these problems. Please simplify and combine all like terms.